Hey guys, hope you had a wonderful weekend, and we are going to be continuing on. This is going to be 6.4. So this is, come on, 6.4. We're going to be talking about logs still. This right here, this first problem is going to be talking about graphing. Right here, graph the log of y equals log base 2x. And they're going to ask you the domain, which is what can x be, the range, what is y, if it touches the x-axis, and if there's an asymptote. And so what are the behaviors? So what we have to realize is that this right here is going to be what we call the inverse of that. If you remember what the inverse is, you literally just switch the x and the y. So you're going to notice all the x's become the y, and all the y's become the x's. And the reason that is because if you take this log, which is y equals log 2x. If I turn this into exponential form, which we've normally done it the other way, so I'll write it again, I'll write it this way. Log base 2x equals y. We've been doing, that means that 2 to the y equals x. So 2 to the y equals x. Yes, that is going to be the inverse of y equals 2 to the x. The reason that we know that's the inverse is when we have the inverse, we literally just switch the x and the y. And if you look right here, the x's and the y's are just switched. So inverses, that's what these are. So you can basically use, let's get a little bigger eraser here. You can use your x and y chart from the other one to get the x and y chart that they got here for what they're doing. The other way is to do this, is to say, okay, this is log base 2 x equals y, and what that really means is 2 to the y equals x. And so I might actually come up, I don't like log form, so I would probably think in my head this, and I would make my x and y chart from this, which is a little different because I would actually be putting in y's and then kicking out x's. Yes, x is still my input and y is still my output, but I would actually kind of reverse it just for this one, just to help make it easier for myself. So like if I put in a 0, anything 0 power is 1. If I put in a 1 for y, that would mean 2 to the first power. That would mean what x would have to be a 2 to get there. If I put a 2 in, this would be a 4. If I put a negative 1 in, the negative would just send, this would be 2 to the negative 1 equals my x. So this would say, hey, you need to kick down to the bottom so it turned into a half. So you could hopefully see all these ordered pairs that they're getting for them. And then the other things we need to talk about are the domain. Well, if I look at this graph, does this thing ever stop going left or right? It looks like it does. Right here, this is the graph we're talking about. If you look at it, it looks like it just keeps on going down. And literally there was if you remember from here, this guy right here, the y equals 2x, 2 to the x, there was an asymptote at x equals 0. So literally when you switch the x and the y, the asymptote also switches. And so now on the new one, which I'll do in blue, my asymptote is going to kick to a y equaling 0, and there is an asymptote right here, and that's why you see this thing just keep going on down forever, and it's going to get closer and closer but never touch that. That's why they say the asymptote is the y-axis, or y equals 0. The domain, it has to be bigger than 0 because, like we said, it stops right here. This graph stops. It never ever touches that, and it keeps on going forever that way. So that's why the domain is here. It never stops going down. It never stops going up. So it's all reals for its range. And if you notice, that's the switch of what this guy was. The domain was, for this one, was all reals. And the range was having to be bigger than 0 for y because it stopped here and went up. Never went down past that. So literally the domain and range also switch when we do the inverse. And then in behavior, as it's getting closer and closer to 0, it's going to negative infinity. As it gets closer to positive infinity, it's going up. So it's going to be positive infinity. That's what that in behavior is describing there. These are all things that we have done in the past. All right. The other thing that we've done in the past that still is going to apply is our movements. So when we have a transformation, that's still, all the stuff that we talked about in the old is still going to apply. So anything inside, like this thing right here, we know that moves it right and left in an opposite way, I think. So this is actually going to move it left 3. And if you look at it, it shifted to the left 3. And that includes everything, right? So it moves everything. So their old asymptote was here. since the asymptote is running up and down, which is, it's going to be moved, it can be moved left or right, so it's actually going to be moved left as well. All those points on there are moved to the left 3. So like if you took this order pair right here, which is 1, 1, it looks like it's going to be 1, 2, 3. It's going to be here now. Okay, that's what that told us. So all the stuff that we've done in the past. So if I have y equals log 2x, and then we have a plus 3. It's not inside the parentheses, so that is going to move it up 3. So all the stuff that we've done, I told you at the beginning of the year, I wasn't kidding. If you understand this concept, it's going to help you throughout this entire process. All right, so the next set of problem is talking about what is the, and you can stop this and pause and look, there are explanations. So if I'm not doing a great job, you can always do this, and then we will have the homework help day that you can come and ask me questions. So if you feel like I'm going fast, you can always pause the video, look back, rewind it, kind of go through it. You can email questions. All right, so what is the equation of the inverse of this? So literally, I have f of x, which is really a y, equals 10 to the x plus 1. Well, what I need to do is switch the x and y, so this is going to become x equals 10 to the y plus 1. And then now I got to make this say y equals. So I got to get everything away from it. So the way that they do this is they say, hey, this is exponential power. If I make it into log form, then it will get this exponent gone. So let's go to an old one. Log 2, 4, actually, let's do 8, equals 3, right? So this was this right here to this power equals that. So that would be 2 to the 3rd equals 8. So we're going to do the opposite of that, right? We have a 10, right? That's basically our 2 from this one. We have our 3, which is basically our y plus 1, and we have our 8, which is our x in this one. So how do we change that from exponential form into log form? So log, if you look, the 2 was here, that became here. So that's the 10 in this case. So this would be log 10, and since it's base 10, I don't have to write anything. If there's nothing written there, it's understood to be a 10. So I'm not going to write a 10. The 10, I'll maybe dash it, would be here, but we are not going to write that 10. And then, you notice the 3 was what it equaled, so this would be x right here, and then equals y plus 1. It's not in the power form, so let me rewrite that better. So same thing written again. Log base 10 x equals y plus 1. Notice now the y is no longer an exponent, which is awesome for what I need to do, because I need to make this say y equals. That's the whole goal of this. So now I just minus 1, and so it becomes log base 10x minus 1 equals y, and there I go. I got my y by itself. So that's one example of that. The next example, B, is the same thing. We're trying to make this become inverse of it. So I'm going to say y equals log 7 x plus 5, and I'm going to go, okay, x equals log base 7 x plus 5, and the goal is to get this to say, whoops, not x, whoops, hello, y plus 5. The goal is to get this y by itself. So what I'm going to go ahead and do is quickly change this from log form, which I don't like currently. Sometimes you like it, sometimes you don't. I'm going to change it to exponential, and that's going to make it become 7 to the x power equals that. And what that allows me to do is get this y by itself. Now all I have to do is minus the 5, and I get 7 to the x minus 5 equals y. And remember, order of operations, this has to do 7 to the whatever power, and then I minus the 5. And there's my equation. So this next problem is kind of similar. It just looks scarier, but it's not. It's the same thing. It says it gives us this is an equation, right? And it says what is the equation of the inverse of this formula? So basically all I'm going to do is switch the r and the a. And you can see, I'm going to try to do it by showing you the book, what they did. so you guys can learn how to read a math book maybe a little bit more, because it does give a good explanation here, right? So it says write the equation in this. So all they did is they rewrote this problem, and then what they did is sorry, I paused the video because I don't think that they wrote what they wanted here, actually, looking at this. They said, what is the equation of the inverse? Inverse, you'd have to switch stuff. They didn't mean the inverse. They just wanted to say, what is the equation if you solved for A? And so all they did, they rewrote the equation, and then they're going to work backwards because we're trying to get A by itself. So if I was doing this forwards, I would do A plus 1. I'd then take the log of it. I'd then times by 12, and then I'd add 25. So if I was working backwards, I would have to get rid of that 25 first, which is why they subtract 25 from both sides. They get rid of this. They minus 25, and then they minus 25 on this side, and that's where they get the R minus 25. And then we said if I was working backwards, this would be 1, this would be 2, this would be 3, and this would be 4. So if I'm working backwards, I'm doing 4 first. I got rid of that. And I get rid of 3 by dividing by 12. So they divide this side by 12, divide by 12, and that's where they came up with this on this side. Right? That cancels out. That gets rid of that one. Now, how do I undo log? I'm going to change it from log form to power form, and this is a base 10 since it's not written. So 10 to this power is going to equal that. That's why we went over that section so hard in the beginning of this section, because we wanted to go, okay, if you have R minus 25 over 12 equals log base 10, it's not written, but it's understood, A plus 1, this to this power is supposed to equal that. And that's where they came up with right here. And then finally, you just minus the 1 from both sides, and then you get A. Now, the final question is, which one of these equations, this equation here, or this one we came up with, would be easier to find the value of A if I give you R? Well, this one would be easier to use because you've already isolated A, which means you don't have to work backwards. You just plug the R right in here, you go in order of operations, and it'll tell you what your A value would be. Okay, so that would be much easier. So if I was doing this one time and someone gave me an R one time and I was trying to find an A, I probably honestly would not work it backwards. I would just plug the R in, and then I'd work this backwards and find my A. Now, if every day someone was going to give me a new R and I was going to have to find the A, then I'd say, forget this. I don't want this one. I would go ahead and rework the formula so I got to here, and so now every day I'll have to just plug in the R and work forwards, and I keep getting my A out every day. It'd be much faster that way and much less brain work. And then finally, they want us to compare this plane's altitude, and it's over the interval from 10 to 15, and so that means that our T's are going to be 10 and 15 that we're going to do. And basically, it's like if I had this line right here and I had this line right here, and I want to go, okay, which one, elevated faster? Well, in this case, it's much easier to see that this plane was going up quicker at a steeper pace. But what we need to do is we know we need to go from here to here and from here to here, and that's basically rise over run. This is rise over run, and whichever one has the bigger slope or change of pace will be the one that's quickly getting higher faster. So that's what they did. Now in this first one, the problem is they don't give us any values. So what they do is they gave us a 10 and they gave us a 15, and in order to get these numbers out, they went ahead and they plugged a 10 into this one. So they plugged a 10 in, and when they plugged a 10 in, they got this number out. And then they plugged 15 into this T right here, and when they did, they got this number out. And then all they did is, this would be my input, 10 would be my input, my output would be the 31,184, and my input for the other one would be 15, and my output would be 34,914. And then the formula for slope is y minus y, which is what they did here, y minus y over the x that goes with it. This is the x minus the x that went with the other one. And then that's how they were going this fast. Now with this other one, they already give you the x and y, so it's much easier. For plane B, they already give you the x and y. There's no need to plug in as far as to find the x and y's that you're going to use. They already gave you them. They're right here. All right, they gave them to you. So all you're going to do is now, this is my y, that's my y1, so I'm going to do 39,000, which is what they did here, minus the other y, which is what they did here. That's where that is. And then your x, that came with the first one, so 15, which is right there, and minus 10, which is right there. When you do that, you get this. Okay? So, which plane had a higher, let's read it, hold on. Which plane's altitude shows a greater rate of change over the interval? Okay? So between the average rate of change for plane A is much greater. It's going up way faster than plane B. All right? You can pause that. You can go back over that. Hopefully you read through this. Like I said, I'm putting these pictures of the book so you can read through. They give you, like, read over here and these things on all these different examples. They kind of talk you through some of the stuff because this book sometimes hides things like where the heck did they come up with these ordered pairs? Well, that's what it says right here. Find A15 and A10 using the function, aka that means take this 10, plug it in, get an A out. When you do, your input will be 10, your output will be 31,184, and that's an ordered pair. And then it also says plug in 15, so you plug in 15 into here, and you get 15, 34,914. All right, so that's how they got all this. Make sure you read these things over here. They give good hints. Read everything. I'll clear the board, and you can pause at any time and read through it and look and make sure you're doing it. Come back to this and look at this while you're doing the homework. I'm trying to keep these videos short and quick so that you can get in, get out. Hope you guys are enjoying this. Please make sure you try to upload on Teams first. It's much easier for me to check. And then if that doesn't work, go ahead and upload into Portal. Other than that, I look forward to talking to you guys probably on Tuesday for a live chat. And we're just going to keep rolling through this. And I hope you guys are staying safe and still having a good time, enjoying family time. And hope you're using apps like House Party and different things like that for you to see your friends. And they have different games and stuff. And just stay healthy and stay mentally strong. All right. Hope you guys have a great Monday.